morning. Last time we were discussing about Foster 2 realization. Of network functions. Suppose you are given ZS and you have obtained YS. YS is say S into S squared plus 4 divided by S squared plus 1 into S squared plus 16. Okay. Then I can write this as K1 by K1S by S squared plus 1 plus K2S by S squared plus 16. How many elements will be there? Can you guess how many elements will be there? How many informations are given to you? I could have had a constant here 10 or so. So, this is one information 1, 2, 3, 4. So, you can have only a 4 element synthesis. Now, each of these factors will take away 2 elements. So, 2 plus 2 4 elements are already gone, alright. So, blindly you can write there is no other term K4S or K5 by S. Okay. So, how much is K1 multiplied by S square plus 1 divided by S, make S square plus 1 equal to 0. So, 10 into 3 by 15. So, that is equal to 2 K2. So, 10 into 12 by 15, make S square plus 16 equal to 0. So, this will be 12 into 10 by 15, 8. So, I can write this as 2S by S squared plus 1 plus 8S by S squared plus 16. Okay. So, this is Y1S plus Y2S. So, how much is Y1S? What are the values of L and C? Corresponding Z1S, Y1S gives me Z1S, which is just inversion of this S squared plus 1 by 2S. So, that is S by 2 half Henry 1 by 2S. So, 2 farads. Is that okay? Another combination Y2S, how much will be the element values of Y2S? Invert it, S square by 8S, that is S by 8 1 by 8 Henry and 16 by 8S. So, 2 by S, that will give me half a farad. Yes. Is that all right? Now, by realizing the network in Foster 1 and Foster 2, we try to see whether these values are within the working range of the available element, the components in the market. So, depending on that, we keep on trying different synthesis methods. It is not necessary that we stick to either Foster 1 or Foster 2. You can have a mixture of Foster 1 and Foster 2. That is also possible. You realize partly by Foster 1 and rest of the network you realize by Foster 2. Okay. If it is a very big ZS function, we can realize like say terms like this K1S by S square plus 1, rest of it we do not realize. So, subtract it from here, whatever is the balance you switch over to Foster 2. Suppose you have started off with Foster 1, realize only one pole by Foster 1, rest of it again you combine and then you realize by Foster 2, that is also possible, any combination is possible. There is another technique realizing the network function by ladder synthesis. Suppose ZS is written as say S, I will take a simple function for convenience here, S into S squared plus 4 by s squared plus 1. Okay, let us take a simple one to start with. So, I can write this as s to the power 3 plus 4 s by s to the power 2 plus 1. S squared plus 1 s cube plus 4 s. If I divide this, I will get s cubed plus s, subtract 3 s, again divide this, s squared plus 1. So, 1/3 s squared, you get 1, 3 s, okay. So, this function can be written as s plus 1 by 1/3 s plus 1 by 3 s, okay. As you have done in high school mathematics, vulgar fraction. So, you go down like this, or in HCF you have done this. This is not LCM HCF, you keep on dividing, this becomes HCF. So, the similar method of division you carry out here, so that the quotients appear as functions of s, some multiple of s. Then we have started off with ZS. So, this is an impedance, this is an impedance of 1 Henry, okay. ZS is equal to this much, this is 1 Henry, then it is 1 by this. So, what is this? An admittance. So, then it is some admittance, part of which I have realized as 1/3 s, 1/3 s is the admittance of 1/3 farad.
So, it is inverse s plus,
Sorry?
not inverse. First term is only directly written s.
Yes.
Second and third term.
Then I have taken s square plus 1.
No, 1 by 3s after.
If I multiply, I will get s squared.
No, here in this fraction.
Yes.
First term is written directly.
Huh.
Second and third term are written.
Okay, okay, okay. I will explain this. ZS is what? I have written s cubed plus 4s by s squared plus 1, is it not? I have written this as s plus, what was the residue?
1 upon 1 by 3s plus 1 by
3s by s square plus 1, is that all right? If I divide by 3s, this is precisely I have done. So, is that all right? So, it will be like this. So, this is an impedance. So, this whole thing is an admittance, 1 by n impedance, is it not? So, this is an admittance, the first element I have realized by 1/3 s, 1/3 s is the admittance of how much? 1/3 farad, Cs is the admittance, so 1/3 farad. And then this is also an admittance, the balance is also an admittance, 1 over that is an impedance. So, this is an impedance, 3s is the impedance. So, that admittance is appearing here as an impedance of 3 Henry, and it stops there. Let us take another example, a little bigger in size. Suppose ZS is given as s squared plus 1 into s squared plus 4 divided by s into s square plus 2 into s square plus 6. Okay. So, how much is the numerator? S to the power 4 plus 5 s squared plus 4 divided by s to the power 5 plus 8 s to the power 3 plus 6 s. Is that okay? Sorry, 12, thank you, 12 s. Okay. Now, in the first division, I want to extract some a1 s plus whatever is the residue divided by this numerator, is it not? Now, obviously, this is s to the power 4, this is s to the power 5, this will not be present. So, I will go to s to the power 5 plus 8 s cubed plus 12 s divided by s to the power 4 plus 5 s squared plus 4. Okay. So, carry out that division. Let us try that. S to the power 4 plus 5 s squared plus 4 s to the power 5 plus 8 s cubed plus 12 s. So, this will be s to the power 5 plus 5 s cubed plus 4 s. If I subtract, I will get 3 s cubed plus 8 s to the power 4 plus 5 s squared plus 4. So, this will be 1/3 s, do you agree, s to the power 4 plus 8 by 3 s squared, and that is all. So, 5 minus 8 by 3, 7 by 3 s squared plus 4. This side it is 3 s cubed plus 8 s. Okay. If I carry out further, this will be 9 by 7 s, all right, that will give me 3 s cubed plus 36 by 7 s, all right. You keep on dividing and finally, you will be getting a 0 residue, all right, and these are the quotients. Okay. So, 1s is the admittance. First element was a1s, that is 0. First one, if it is zs, if you are starting from zs, first one is a1s, means a1 Henry. Next one, it will be 1 farad. Now, this a1 is in this particular example is 0. Next, this one is an inductance of 1/3 Henry. Straight away these quotients with s, the term associated with s, this gives you the element values, 1/3 Henry, then 9 by 7 farads and so on. How many elements are there? 1, 2, 3, 4 and a constant 5. So, there will be 1, 2, 3, 4, 5. It will end up like this. Okay. So, if you go from Zs with the highest power of s, Zs, or it may start with Ys. For example, here the because the numerator is of lesser order. So, it started with a Ys, the first element is not present, but I have started with s to the power 4 polynomial in this order and s to the power 5, 8 s cubed and so on. So, if I go from the highest power of s, that is the polynomial is written in descending order of s, and then carry out the division, I get a structure like this, starting with an inductor in series, capacitor in shunt, inductor, capacitor, inductor, capacitor and so on. This is known as coir 1 synthesis. if instead we started with, say, earlier example I will take, that would be better. Say ZS we had S cubed plus 4S by S squared plus 1, is it not? That was our first example. We got inductance, capacitance, inductance. So, series element was inductance, shunt was capacitance. If we reverse the order of the polynomial, that is, if we start in ascending order of S, and carry out the division, what do we get? Yes, let us see, 4S plus S cubed, 1 plus S square, 4S plus S cubed. So, this one will be 4S, then 4S cubed, you will get a negative sign. So, this division fails. So, put it below this, so you get a negative term. So, it is truncated. So, I rule out this possibility. So, I can write ZS as 1 by 1 plus S squared by 4S plus S cubed. That is possible. I start with YS basically. So, if I have 4S plus S cubed 1 plus S squared. Now, if you carry out the division, it will be 1 by 4S. So, I will get 1 plus 1 by 4 S squared, all right. If you divide 3 by 4 S squared, 4S plus S cubed. So, what do I get here? 16 by 3S. Do you get it? Do you get it? So, that will give me 4S, S cubed and 3 by 4 S square. So, it will be 4 by 3 S. So, the elements we get are ZS equal to 1 by this. So, this is admittance. So, it starts with an admittance of element 1 by 4S. What is the admittance of 1 by 4S? What is that corresponding element? 1 by 4S is the 4S is the impedance. So, 4 Henry. Okay. Then 16 by 3S is the impedance. Alternately, it will be impedance admittance, is it not? So, 16 by 3S is the impedance. What is this? 3 by 16 farads. Okay. And then 4 by 3S is the admittance. So, 3 by 4 Henry inductor. Is it all right? That means, now I have another network. If I reverse the order of the polynomials, put them in descending order, in ascending order, and then carry out the division such that the quotients are always 1 by S, multiples of 1 by S. Earlier it was coming as multiples of S. So, alternately it was inductance, capacitance and so on. Now, this is something divided by S, all right, and 1 over that coefficient is the element value, 1 by 4. So, invert it 4, 16 by 3 invert it 3 by 16, 4 by 3 invert it 3 by 4. So, now the element values are just inverse of those coefficients of 1 by S, all right. and shunt elements are inductances, series elements are capacitances. So, this is known as coir 2 realization. Okay. This is coir 2 realization. So, if we have say y s, let us take an example. Y s is s into s square plus 10 by s square plus 1 into s square plus 16. If I ask you to realize it by coir synthesis, what will be the coir 1 synthesis? Let us write it s to the power 3 plus 10 s divided by s to the power 4 plus 17 s squared plus 16. Is it all right? So, they are all in descending order. So, in coir 1, this is y s. I should try to get s to the power higher power, s to the power 4 in the numerator, then only I can divide. So, this can be written as z s equal to s to the power 4 plus 17 s squared plus 16 divided by s to the power 3 plus 10 s. Okay. And then carry out the division, s to the power 3 plus 10 s, s to the power 4 plus 17 s squared plus 16. So, s to the power 4 plus 10 s squared, 7 s squared plus 16, s to the power 3 plus 10 s, 1 by 7 s, 16 by 7 s. Okay. Is that all right? So, 70 minus 16, 54 by 7 s, and here you have got 7 s squared plus 16. So, 49 by 54 s, that will give me 7 s squared, and then 16, 54 by 7 s. Okay. So, this will be how much? 7 by 54 into 16. Okay. So, you get 1 Henry inductor, 1 by 7 farad capacitor, 49 by 54 Henry inductor, and 7 into 16 by 54. So, 112 by 54 farad capacitor, 49 by 54 Henry inductor. So, this will be the realization. Okay. If you reverse the order and start the division, coir 2, if I am asked to realize this by coir 2, y s was 10 s plus s cubed divided by 16 plus 17 s squared plus s to the power 4. Now, when you are carrying out coir 2 division, you must see the first two terms in the division. If I divide 10 s by 16, I will get in the quotient s, I should get 1 by s. So, obviously, this will fail. So, I will write this as 1 by 16 plus 17 s squared plus s to the power 4 divided by 10 s plus s cubed, and now carry out the division. with quotient as 1 by S and its multiple. Is that okay? So, you will get coir 2. Coir 2 elements will appear as inductor in shunt, capacitor in series. You had 2 inductors and 2 capacitors here. So, here also you will have 2 inductors and 2 capacitors. This is a very general form. So, for this example it will be like this. Okay. So far we have studied 2 element synthesis with L and C. What will be the network function for RC elements if I have only R and C? What will be ZS R plus 1 by CS? Okay. So, that is RCS plus 1 by CS. So, it is K into S plus alpha by S in this form. So, the roots are 0 at minus alpha, this is S plane, it is real, and pole 0 at minus alpha and pole at the origin. Okay. Let us take R and C parallel combination. What will be the values? RCS, R by RCS plus 1. Okay. Is it not? So, that is K by S plus alpha. So, pole is at minus alpha and 0 is at, when is it 0? When S tends to infinity. So, when S is infinity, I will show you with a break, it is a 0. Okay. Is a real imaginary function. Is that okay? When we have a function like this, say 1 ohm resistance, 1 farad, I am just taking 1, all ones. What would be the pole 0 configuration? Let us simplify this. 1 plus 1 by S plus 1 by 1 plus S. This is 1 and 1 by S parallel combination, that will give you 1 by 1 plus S. So, that gives me S plus 1 by S plus 1 by 1 plus S. So, 1 plus S whole square plus S squared 2S plus S 3S, all right. You can find out the roots. What are the roots? S square plus 3S plus 1.
S plus 2 is plus 1. S minus 1 minus 2 is the root. No, sorry. Extend, sorry.
Minus 3 plus minus 9 minus 4 by 2. Okay. So, how much is it? Minus 3 plus minus root 5 by 2. Sometime back we made a slip, I do not recollect in the earlier lecture whether we got these values. Minus 1.5 plus minus 2.2 1.12, so 0.38 and 1.62. Did you get the same values? There was a slip there, minus 3 by 2, the same values. Minus 3 plus minus root 5 by 2. Did I get minus 3 plus minus root 5 by 2? So, that is 1.5 and 2.24 by 2 1.12. So, this is 2.62 and 0.38. Is that all right?
Yes, 0.38 and 2.62. Yes, sir.
Okay, fine. So, it will be S plus 0.38 into S plus 2.62 divided by S plus 1. So, where are the poles and zeros located for this? This is the real and imaginary axis of S plane. Okay. So, at minus 1 it is a pole, at 0.38 it is a 0, minus S into S plus 1. Thank you very much. So, S is a pole, okay, S is a pole, 0.38 is a 0, again minus 1 is a pole and 2.62 is a 0. What about infinity? At S equal to infinity, it is S square by S square 1. So, it is neither a pole nor a 0. Okay. So, if you have observed the pole 0 configuration for these three, you can take a few more examples and then see for yourself. Either it may be starting from the origin or it may not start from the origin, but the first one is a pole, it starts with a pole. As you go along the negative real axis, first of all poles and zeros are all on the negative real axis, RC circuit, there is no scope for oscillation. So, poles and zeros are all on the negative real axis, and the first one closest to the origin is a pole, first one starting one is a pole. Again poles and zeros are coming alternately, pole followed by a 0. Infinity can be a 0 or a pole, but it is not necessary to be either of them. Okay. It will start with a pole and then alternately poles and zeros will be appearing. Okay. So, if you are having a function, if you are having a function ZS equal to S plus 1, S plus 4 into S plus 10 into S plus 16. Is it an RC network? It is not an LC network. Is it possible to realize this by RC elements? Poles and zeros are coming alternately, minus 1, 4, minus 10, 16. So, poles and zeros are interlaced. Okay. First one is a pole, then it will be possible to realize it by RC combination. If in the impedance function first one is a pole, obviously in the admittance function first one will be a 0 and there should be poles and zeros should be appearing alternately. Okay. Then this is an RC network. If I have ZS given like this, say this particular example, I can make partial fractions a by s plus 1 plus b by s plus 10, okay, plus some constant c, all right. D by S is ruled out because S is not there as a pole in this particular example, alright. Otherwise, this will be the general form. In this case, D is not there. Is it possible to have C? Yes, it is S square, numerator is also S square. So, let us calculate the values of A, B, C. What will be A multiplied by S plus 1, we are considering ZS, and then make S plus 1 equal to 0, it will be 3 into 15 by 9. That is equal to 5. B similarly, if I multiply by S plus 10, make S plus 10 equal to 0, this will be minus 6 plus 6 and minus 9. So, 6 into 6 by 9, 4. Then if I make S tending to infinity, this will vanish, I will be left with C. So, S tending to infinity means S squared by S squared, 1. Okay. So, this can be written as 5 by S plus 1 plus 4 by S plus 10 plus 1. Okay. 5 by S plus 1 is what? If I make S tending to 0, it is 5 ohms. If I make S tending to infinity, 1 by 5 farads. Similarly, here it will be 4 by 10 ohms. S tending to infinity, it will be 4 by S. So, 1 by 4 farad and then 1 ohm resistance. Okay. This will be Foster 1 synthesis for ZS. Is that all right? Foster 1 synthesis for ZS. There is something very interesting here. If you try to realize Foster 2, what is the form of YS function for RC series elements? What is the admittance of this? R plus 1 by CS is the impedance. So, 1 by this, is it not? So, 1 by RCS plus 1 into CS. So, now the admittance function, if you consider admittance function of this element, it is Ks by S plus alpha in this form. Unlike the impedance function, which is K by S plus alpha, admittance function for an RC network is Ks by S plus alpha. So, let us realize the same network by Foster 2, that is starting with admittance. So, mind you, Foster 1 starts with impedance, Foster 2 starts with admittance, Coir 1 starts with a ladder structure with a descending order of S, S to the power 4, S to the power 3 and so on. In case of Coir 2, it is in the reverse mode. So, let us see this particular example YS S plus 1 by S plus 10 by S plus 4 into S plus 16. If you do not take note of this, if you try to find out A by S plus 4 plus B by S plus 16 plus C, you will end up in trouble. Let us see what you get. What will be A? If I multiply by S plus 4, make S plus 4 equal to 0, this will be minus 3 into 6 divided by 12. So, you get a negative value. You cannot realize minus, this is 3 by 2 minus 3 by 2 s plus 4, that is not possible, is it not? Minus 3 by 2 into s plus 4, this is not the admittance of any RC network. So, you will end up in this problem. Suppose now we put a s by s plus 4 plus b s by s plus 16 plus c. Now, let us see what will be the value of a. Multiply by s plus 4, make s plus 4 equal to 0, s is equal to minus 4. So, on the left hand side, or multiply by s plus 4, divide by s and then make s plus 4 equal to 0. So, this will be 3 minus 3 into 6, okay, divided by minus 4 into 12. Is it all right? So, minus plus 3 by 2, is that all right? 3 by 8, sorry, 3 by 8. How much is b? Similarly, multiply by s plus 16, divide by s and then make s plus 16 equal to 0. So, that gives me 15 into 6 divided by 16 into 12, all right. So, 15 by 32, is that okay? So, we get this as 3 by 8 s and here s plus 4 plus 15 by 32 s plus 16 and c by the same logic, if I make s tending to infinity, it will not work here, because here s by s, that will be again giving me a. So, make s equal to 0, this will vanish, this will vanish, this will be 10 by 64, is that all right? 10 by 64. So, what are the element values? I have got y1 plus y2 plus y3. I can write this as y1, y2, y3. So, how much is y1? It is 3s by 8s plus 4. If I invert it, corresponding zs will be z1s will be 8s plus 32 by 3s, that is 8 by 3 plus 32 by 3s. So, one resistance, one capacitance. This is 8 by 3 ohms and this is 3 by 32 farads. Okay. Similarly, y2 will be another RC combination. How much is that? 32 by 15 by 32. So, Z1 Z2s equal to 32 by 15 s plus 16 by s. So, 32 by 15 ohms resistance, okay, and 32 into 16 by 15. So, 15 by 512 farads. Is that all right? Then I am left with another admittance of y3, that is 10 by 64 mho. So, 64 by 10 ohms I will put on this side, y3, that is 6.4 ohms. So, this will be the realization by Foster 2. Is that all right? So, whenever you are given a network function ZS, where poles and zeros are appearing alternately in this form S plus 1 into S plus okay, guess whether this will be an RC network S plus 2 into S plus 1, 2, 9, 10 will it be an RC network? Will it be an RC network? Why?
0 is coming close.
Poles and zeros are alternately coming.
0 is close to origin.
0 is close to the origin. So, this is not realizable by RC. We have observed for RC network, poles will be closest to the origin. The first one will be a pole if you calculate these roots. Is it all right? So, what could be this function like? Let us see. Can I break it up into some AS by S plus 2, but if I have YS in this form, then it is an RC network. Suppose I have this given as an YS admittance function, then it is an RC network, is it not? For ZS, the closest one, closest to the origin should be a pole. That means, for YS, closest to the origin should be a 0, and we have got factors for that. Suppose ZS is given in a similar fashion, for which we have already factorized in this form like the previous one. Okay. Let us calculate just one of them. What is the value of A? If I multiply by S plus 2, divide by S, make S plus 2 equal to 0, it will be 1 into 7 divided by minus 2. Okay, I will not put minus 2 because minus 1 is also there. 2 into 8. So, 7 by 16. So, this will be 7 by 16 into S plus 2 into S. This is an admittance function, is it not, for RC network. Suppose this is an impedance function. What would be the impedances elements? Suppose this is an impedance function. We start with this as Z1. If I make S tending to infinity, this will go 17 by 16, S will get cancelled, 17 by 16 ohms resistance, is it not? And if I make S tending to 0, then this will go 17S by 16 into 2, 17 by 34 what? 17 by 34 into S is the impedance of what? 17 by 34 into S is the impedance of what? It will be an inductance, Henry. 17 by 34 S means 17 by 34 Henry. So, it is basically a parallel combination of RL elements. Is that all right? 7 by 32, 16 into 2, 32. Oh, 7, not 17, sorry, not 17, thank you very much, it is 7. 7 by 16 ohms resistance and 7 by 32 Henry inductance. So, if you are having in the impedance function the first factor as a 0, then it will be an RL network. That means, admittance function of RC network and impedance function of RL networks are identical. Conversely, impedance of RC network and admittance of RL network are identical. Poles and zeros, thank you. Poles and zeros will be alternately coming. if in the impedance function it starts with a pole, it is an RC network. If it is in the if it starts with a 0, it will be an RL network, and then the method of partial fraction is identical. All right. The partial fractions that you have made for admittance of RC network will be similar to impedance of RL network, is it not? So, in the next class we will be taking up some tutorial exercise on synthesis by different techniques of different RL, RC and RC LC networks. Thank you very much. Okay, good morning friends. Today we will have a tutorial session. We will be working out a few problems on Bode plot and positive real functions, if possible something on synthesis, 2 element synthesis of driving point impedance functions. The first problem is given a Bode plot like this, this is 1 by root 3 t, this is 1 by t, okay. This is 12 dB per octave, and this is minus 6 dB per octave. This value is 3 dB. Estimate these frequencies omega c and omega d, this frequency. Omega c is how much, omega d is how much, and then determine Gs. Okay. So, for this problem, this is the dB gain, this is the 0 dB line. So, could you suggest the function like Gs, what it would be like? Gs will be some constant times, it is a slope going up at this frequency. Okay. So, 1 by root 3 t, let me call it omega 0, okay, omega 0, then it will be 1 plus s by omega 0 whole square, this is 12 dB per octave whole square, all right. Then okay, 1 plus s by, okay, 1 by t will be how much then? Root 3 omega 0. So, if I call this 1 by t is equal to root 3 omega 0. So, s by root 3 omega 0, then any other answer? There are two black boxes. This is L Henry, R resistance, C farads. The condition is R squared is equal to L by C. ZS show that ZS in both the cases are same, that means this ZS is having a value R. Given this, prove this. Okay. The second part of the question is, this is given, you have to prove this. This is part 1. Part 2, by any measurement, any external measurement, can you identify this one from this one? Can you identify that this is a pure resistance and this is not? Okay. We will take up, okay, identify by any measurement, that means any external measurement, you carry out any experiment that you want, make any measurement and identify the networks. Omega squared minus root 2 A1 omega squared. Okay. One may write this squared term minus omega square into 3 by 4 plus root 2 A1.
Sir, above A1 less than 9/4 is that above 9/2. Root A1 earlier than
Root A1, sorry. So, A1 will be square. Okay. Thank you very much. So, here is one condition. Does it mean for any value of A1 it will be negative? Though there is a negative term, but this value is generating more values. I mean this whole thing is giving me sufficient margin maybe. So, for any value of A1 this cannot be tested. So, I should always put the minus sign here and then plus something and then try to see if in that plus term there is any possibility of getting a negative value, alright. Otherwise, this will not be able to identify the actual range of A1, you may be misled. Then the second part is, I think the time is over, I will continue with this in the next class.